Hello, everyone. Thank you for joining us at B-Sides Tampa 2022. I am excited to introduce our next speaker, Christopher Peacock. He will be giving a presentation on the process of detection engineering. Here's just a few of his many experiences: cyber threat intelligence analyst, cyber threat hunter, tier 3 SOC analyst, incident responser. He also has experience in multiple industries: and energy, finance, healthcare technology, and defense. Please welcome Christopher Peacock.
Thank you for that introduction. Really appreciate it. Thank y'all for being here. Let's see if we got slides up. Okay, there we go. Thank y'all again for getting that set up. Really doing a great job today, guys. So the process of detection engineering. First off, who am I? I'm Christopher Peacock. I started my journey at Alpha 2, where I did help desk, network administration, system administration, that whole jazz. I worked up. I went to General Dynamics, where I started working as a SOC analyst and conducting Purple Team. Back in that time, PowerShell was just coming out as something that was like really used by pen testers and also adversaries, but we didn't really have EDRs yet. So it was how to, go out and enable the PowerShell logging around that. From there, I went to Raytheon, where I did intelligence. I did incident responder, SOC 3, led the threat hunt team, which is now more kind of what has become detection engineering, right? The threat hunts, at the end of the day, you end up with a query that you can actually deploy as an alert. So it's kind of like an automated threat hunting or detection engineering, however you want to label it, multiple ways to call it, but that's what it is. And then now I'm at Scythe, where I do adversary emulation and detection engineering. So that's actually going out, finding what bad guys are doing, extracting those procedures. We're getting down to procedure level in the TTP phrase. And then we work on doing detection engineering. So we map those to Sigma so that you can deploy them wherever you need to, or we create Sigma rules and contribute that to the community. So one of the goals of this is to find suspicious activity. And one of the areas that we like to focus on is post-delivery. Reconnaissance, that's where someone's scanning, things like that. You're not going to get really good return on investment there. Delivery and exploitation, we're really relying on our vendors. We're relying on our firewall, our WAF, relying on the email gateway, things like that. And then once we get to installation and command and control, actions on objectives, that's where we want to catch them before impact. Ransomware isn't click and spread everywhere. That was WannaCry, that happened once. But most of the time, they're actually going through a whole attack chain in the environment, and you can actually catch them pretty early before they get to impact. So that's what we're about. We're about catching those adversaries early before impact. What are the strategic drivers of this? So when we look across the strategic drivers of this, we have two of the foundation, which makes the base here. So we have the operational capability or capacity, and that's how the analyst can work with the data. And then we have the data collection. So those two things are the foundation. But then when we add threat understanding to it, that's what evolves us into being a threat-informed threat hunter or detection engineer. So with data collection, we need to understand what data are we collecting. And then from there, we can figure out where we can do analysis on. If we don't connect, or if we don't collect named pipe, then we're not going to be able to do detections around that. We have to understand our gaps and what we're collecting. And then finally, where is it collected? Oftentimes with an EDR, you have the data in the EDR, and it might only send alerts to the SIM. And the SIM's only getting alerts, so you can't do your detection engineering in the SIM. You have to go to the EDR. So we have to understand that. And then finally, we need to know how we prioritize our data. So one way we can prioritize our data is actually understanding what data sources are applicable to the most techniques and sub-techniques. So here we see command execution, process creation, file modification. Those are all very important data sources to cover the attack matrix. And then the other one is the operational capacity. And this is just understanding that we need good tools and we need good analysts to work together. That's really what it's about. If you have a tool or it's spread across multiple tools, it's going to slow your analysts down. The other thing to take into consideration is the time factor. And that's the thing, is when we have inefficient tools or it takes too long for us to run queries, it's going to slow us down as detection engineers or threat hunters. And then finally, we have threat understanding. And this is where that CTI bit comes in, of knowing what's going on in the threat landscape, what actors are doing against us, our org. If I'm elementary school, I don't really care what North Korea is doing to South Korea. That's not my threat profile. I need to go out and study what ransomware actors are doing. And then we want to focus on the procedure. We don't want to focus on the technique level, because if someone tells me that they dumped LSAS, I don't know how they dumped LSAS. So I can go out and I can grab an atomic red team test, which is great, but I don't know if that actually aligns with what my adversaries are doing at the time. And then we also don't want to focus on IOCs or threat feeds, because these change very often. So the process looks something like this, where we get direction from the CTI. We know what's happening in our space. We do our collection after our direction. Also, direction hopefully includes some sort of purple team exercise, so that you actually have those that data in your production environment. You want to see what it would look like in your environment, so that you can also test, do we have alerts around it or do we not? And then we do our collection and then our processing, and finally we disseminate it back out to SOC and our stakeholders. So cyber threat intelligence, this is a big area. I've heard multiple times people say, I pipe my threat intelligence right into my SIM. I'm like, really? Because threat intelligence is very hard. So one thing to think about is IOCs are not threat intelligence. What we're talking about with threat intelligence is actually understanding who's going to attack us, who's in our threat landscape, and then what those threat actors are doing at a procedure level, okay? And why we do this is because the procedures that are ran, adversaries have habits, they have training, they have tools. They also have guides. If you haven't seen the Conti playbook, literally it tells them step by step of what to run. And like every time there's a Conti incident, they're doing NL tests, net, all these different steps, so you can catch them early. But yeah, you can check out the guide. It's awesome, just from an intel standpoint, to actually see it and lining up with things like the DFIR report, which is a great resource to have. And I think I went out of, there we go. So direction, we have that CTI, we understand what our adversaries are doing at a procedure level. And then we say, do I have detections already? Because we need to actually emulate those procedures so we can see if we have detections or not. And then from there, we need to figure out how to catch it. But first, we'll go ahead and run it. So in this example, we'll go ahead and run the procedure and see if we catch it or not. And that's how we get direction, is actually running those procedures. And this is what it looks like at the end for the direction side, where we've put together a plan of what the adversary is doing at procedures level. We've mapped it to alerts, and then we see where we have alerting gaps as well, so that we can work on doing engineering around those. Next, we have collection. So with collection, we want to go ahead and start seeing what we have in our events. We want to see what's actually in our data sources. And with this, we can go and we can leverage detect to actually map out our data sources to see where the detections might be. And then we also want to identify and catalog any visibility gaps. So like I said before, lots of EDRs, they won't actually log the pipe names creation, so you can't do certain detections around that. And as we look and we start understanding the data, we can start hypothesizing. So here, this is one way that we can map this if you're new to it, where you go to the MITRE ATT&CK page and we see that PowerShell is going to have, they call these detections, but it's really like log sources. So we see that there's a source of process, and we see that there's a component of process creation. And so you can go to any of the technique pages. Once you have your procedure, you map that procedure to the technique, and you can figure out your data sources needed. The problem is attack ends here, and you have to figure out what your actual event logs are in your environment. And the way you do that is you leverage detect. So with detect, you can add your data sources in. So here we have process creation, and I can see my products of where that actually resides, and then I can quantify my data quality in there. And this is what it looks like. You know, CISOs love this type of overview. It shows actually where we have visibility into certain data collections. This isn't to be construed as actual coverage from an alerting standpoint or a response standpoint, but this is actually a good way to show where we have not detection gaps, but logging gaps. So hypothesizing, this is where we've started analyzing our data, and we need to look at ways of doing the actual alert engineering. So we start out, we cast a wide net because we want to get as much malicious activity that we can, and then we start tuning that out. And then we narrow it down, and we want limited false positives. If we deploy a lot of false positives, then we're going to be in trouble. Our SOC's not going to be able to actually respond to that alert. And then from there, we also want to embrace so that we're going to have a few false positives, because a lot of what we're looking at is looking at living off the land techniques, which are using things built into Windows. So we want to find suspicious activity, and it might get flagged by a system administrator or something like that. So developing a hypothesis kind of looks like this, where we actually have Microsoft delivers threat actor targeting SolarWinds with a 0-day exploit. So with this, we see that we have the MSHTA application making a call out to a public IP address. So we can start saying, if we know what MSHTA does in our environment, does it normally connect outbound or not? So we can start thinking about, is that a detection opportunity? We also see who am I execution. So we can start thinking like, do we need to catch that? We also see a couple things that we'll go over when of how we ask more questions to start developing our hypothesis or our search query. So one of the things we want to consider is when we're looking at a procedure is, what is the procedure doing? And how is it made, or what makes it malicious? How is it used maliciously? What's the threat actor really doing here? So what that looks like here is we see that command prompt is launching who am I, and they're enumerating what they're running as, and then they're piping it out to a text file. So now we know what the adversary is doing, and then we can say, well, what do our system administrators do, or what does our help desk do? Does our help desk actually pipe out who am I to a text file? And we can start thinking about ways of hypothesizing around that. And then the other thing is when we start hypothesizing, we look at how often does this happen in normal operations. So in my environment, how often does CMD launch who am I? Or like we said before, how often are they actually piping it out? That redirector is not very common for who am I in most environments. If we're at a small company, a few hundred workstations, no one may even use who am I. So that's another thing to consider as well. So these are just things that we're starting to try to baseline in our environment. And then we look at, are there parent processes? So when we look at the CMD process chain that spawns off, we can look at what actually started this process. And once we understand what starts this process in our environment, we can tune it out potentially. Or we can look at how often does CMD launch who am I? Maybe who am I, my environment launches, but it only launches from a different process. So I just tune that out and I flag on any who am I execution, because that's one of the first things attackers do when they get on host. They want to know who they're operating as. And then we can also look at, are there common child processes? So what we have here is just a common parent-child relationship. Well, not a common, but a commonly malicious one, where when word is spawning command. So that's one that we can tune into. We can look for, rare processes coming off of when word that attackers are using, such as command prompt or PowerShell or run DLL, things like this. We also see Excel spawning run DLL 32. So these are things that we can start looking to as we do threat hunting and detection engineering, is what are the child processes that I can tune into or out of? If you want to catch, an Apache 0-day, like probably 9 times out of 10, the Apache exe process is going to have some sort of scripting interpreter off of it, such as PowerShell spawning off that Apache process, because the attacker needs to run commands. So the other thing we need to look at is command line parameters. Often when we're trying to do tuning, we're looking at a certain process that's used across the network because it's living off the LAN, binaries and scripts. And if you're unfamiliar with that, that's just common applications that are built in to Windows, or there are other Windows executables that attackers can bring in. So we need to look at what are suspicious command line parameters around those. And then we can tune into those potentially, like in this case, or potentially if I'm looking at one setup with an application and one process or multiple processes keep having the same line, the same command line parameter, I can tune that out as well. And then the other thing we want to look into is the users. So a lot of times, certain processes might run a system. So if those processes are running as something that's not a system, then that's interesting. Or if they're running as, a typical user and they're not supposed to usually run as a typical user, that's interesting. So we can look at that. The other area of suspicious users is we can say, all right, for who am I, that's typical for help desk to execute. But should someone in HR probably be executing who am I? Let alone should someone in HR probably be launching a command prompt? That's probably a little suspicious because I don't know too many people outside of IT who launch command prompts. And then finally, we also look at, does the process make network connections? This is a huge one for almost anything inside C Windows folder path. If it's going outbound, you probably need to start baselining that and look for suspicious activity. But in this example, we see where PowerShell is going outbound. So that's just an example where what we want to do is we want to baseline, does this process, does it call locally to local host? Is that common? Sometimes you'll have certain processes where they don't call to local host, and you need to start flagging if they do call to local host. Or we look at private IP spaces and say this process only should talk to private IP spaces, in our LAN, but it shouldn't call outbound. So then that's another area that we can look at. And then finally, external IP. So we need to start understanding what this process communicates to on a common basis so that we then can flag when it's suspicious. And what this looks like, it looks like when we're tuning is we cast the wide net first. So we cast the net and we usually get a bunch of benign events. And that's where we start. And that's what casting a wide net kind of looks like in a visual reference. And our goal is to get down to this aspect where we have a few benign events and we get most of the malicious events. And the way we do this, though, is through testing, and we start seeing a bunch of different ways that the attackers are using those tools. Run DLL32, things like this. We're starting to get a bunch of data generated around that, and that's why we want to do emulation in our environment, in our production environment, to actually verify our detections and if we need to change them. One thing we like to talk about too is don't go too small or too precise. If you go too precise, then you end up with something like this, where you're actually missing a lot of the malicious events. And if you do this, it's not good because you're missing the bulk of the events that the rule could be covering. And what this does is it either allows you to miss alerts that you should have had, or it means that you're going to have to create a bunch of different layered alerts. And then you just have a lot of alerts, and that slows down the systems. One thing we also want to mention is that with the nature of finding suspicious activity, sometimes when you actually go out there and you look at it in your environment, you might think, yeah, I'm going to catch this one guy. And then you realize that you have a bunch of benign events that come along with it. So I just want to say, not every procedure that a adversary uses is going to be a good detection opportunity. Sometimes you just don't have a good detection opportunity and you have to accept that. But at the end of the day, we want enough lasers in our vault scanning everywhere so that when a hacker comes in, they trip one of those lasers. So a quick example of this is the tuning of WMIC. So in our environment, we went out and we looked for WMIC. It's a common living off the land binary and script built into Windows. And what we have here is we look for the parent processes that were spawning it. And as you see, we have an Amazon agent that's spawning it a bunch. But then I have my Scythe emulation campaigns and a PowerShell that came off of one of them. Those were also spawning it. So this is a quick win in an environment where I can just go out, I can look for WMIC. Should it be spawned in my environment? Okay, it's spawned by this. We tune that out, and now we're already finding suspicious activity. So that's a perfect example right there. And then we get to dissemination as well. And with dissemination, we're delivering to the stakeholders. And this could be delivering to SOC, obviously in the form of an alert. If we did good threat hunting, we have a tuned alert at the end of it that we can deliver to SOC, and now we can go threat hunt on something else instead of having to threat hunt on the same thing, month after month. And then one of the other things we want to do is maybe we give it to management. And one of the things we give to management is, we can take our developed alerts, we can map them to MITRE, and we can throw it up on a graph for them. So that's one thing to think about as well. And we can also give it to the CTI team. And then we can also document log sources so we know what tools are giving us the most value. And then finally, this is always a circle that's ever continuing because adversaries are always updating their procedures. And then also, if you have a red team, you can tell the red team that, hey, we have this rule now, or we put a block in place, or whatever it is, and we want to know, hey, red team, what would you do to bypass this, or how would an adversary potentially get around this so it wouldn't flag in our environment? And then the red team can say, well, instead of running who am I, we'll just enumerate this environment variable instead. And then you have to go and you have to do detection on that. So that's what it looks like from the dissemination standpoint. And with the red team, kind of, if you have that, implementing it back so that you're constantly doing that cat and mouse game and hardening your environment with detections. And then we also have the dissemination structure by Palantir. They have the ADS framework. It's a great in-depth framework, but being Palantir, they are a defense contractor and they have lots of resources and they have a huge team. So I want to say that you don't have to go out and do this to the T. Some people, they're like, oh, I need to do the full framework. And I'm here to tell you, you don't need to do the full framework, but do what works for your environment. I recommend going and checking it out. Take what you need, what fits into your environment. And then from there, you can actually implement what you need to implement. So let me bounce back because I actually skipped a few slides. I did this in Google Docs and then exported. And I think when my, so it's just blank. All right, well then I'll just talk manually to it. So for those of you unaware, by the way, of the David Bianco's Pyramid of Pain, David Bianco came out, this was after Mandiant APT-1 report. The APT-1 report really changed the industry. It was the first time that we said, hey, it's not just malware. It's not just malware is bad, clean up malware. We went out and we actually saw that there was adversaries behind here. There's actually procedures that they do. So what David Bianco said is, hey, the IP address, they can change that really quickly. I don't know if any of y'all were in the talk earlier. John, though, was talking about how you can just script out infrastructure as code. So adversaries can literally spin up and then move IPs constantly. And then every time they do a new payload, then it can be a new hash. So when we're trying to look at these IOC feeds, what we're looking at is just old artifacts left behind by an actor. So IOCs, there's hashes and stuff. Those are good checks to make sure that none of that stuff was in our environment as far as cross-referencing. But what we really need to get to is as you move up David Bianco's Pyramid of Pain, he gets to tools, and tools are good because we want to catch something like Mimikatz, right? Because it's used everywhere, and people change the hash though on it constantly. So if you're trying to catch the hash, you're not doing a great job. But you need to be able to catch Mimikat, the tool, or Mimikittens or Mimidogs or whatever they name it. That's where we get to tools, and we need to catch that. And then finally, when we move to the top, at the time, I believe this was like 2013, he had the TTPs at the top. And with cyber threat intelligence, with the TTPs, everyone's kind of lumping that together to say that the adversary did this TTP and this TTP. So when we see it, though, when we look at the actual technique, it might be credential access. So if I communicate to y'all as a group and I say, hey, Purple Unicorn yesterday did credential access, how are you going to go out and make sure that you're secure from that fuzz or from that Purple Unicorn dump, with credential access? You don't know how to test that. So then we also had the technique level where we say, okay, Purple Unicorn dumped LSAS. That's how they got credential access. But we still don't know how they actually dumped LSAS. So this is like where I say, if you're familiar with the Schitt's Creek like scene where they're going, how do I fold the cheese? It's how do I fold the cheese? Because at the end of the day, if you tell me that they dumped LSAS, I don't know how they did. Did they use Mimikatz? Did they use Proc Dump? Did they do it any of the other 20 ways? Did they come up with a new and novel way of dumping LSAS? I need to know so that I can actually replicate that in my environment. So the other thing that we need to know is, so after David Bianco published this after APT1 report, it wasn't until like 3 or 4 years later that attack came out. And everyone's trying to map stuff to attack now. And with that, what we have to do is we have to understand what attack was meant for. It was meant to communicate. It was meant so that I could go out and I could do a report and tell you what happened in my environment without handing over every single command line procedure that the adversary did. So attack was meant to take that, tag that, and then communicate it out to the masses. That's what attack was meant for. But now, it's kind of like the Frank's Red Hot sauce. Everyone's putting attack on everything, which I love the attack team. They're great, but sometimes some things attack works for, some things it doesn't. So what we're really trying to do, and what I'm trying to say is, you need to get down to that procedure level of what the adversary is doing. If you're not doing that, you're not having threat-informed detections. So we need to go out. If you are getting, you can have this from multiple sources too. If you're ransomware, the DFIR report does a great job on opportunity adversaries. They take malware, they detonate it, they look at what they're doing in their environment at the procedure level. They tell you every single procedure. So then you can run that in your environment, and then you can do your detection engineering on it. And that's really what the whole process comes down to, is starting out, figuring what the adversary is doing, because they have those habits. I don't know if I've actually said yet, because I'm trying not to, but I have a habit of saying on stage. So if you were to do something and you're like, out of all the speakers here, that one's probably Chris, because they said 20 times. But I have habits. Everyone has habits, or they have training as well. If you are going to a nation state to do hacking, guess what? You're going to get training. And I'm going to tell you, they don't change training that often because they have to be able to push people through. So the training is going to be similar. A lot of 3-letter agencies send their students or their employees through SANS. So a lot of them are getting SANS training, which is going to be the same training over and over again. By the way, shout out to George. I'm not trying to badmouth SANS. He's probably on the Discord saying something right now. But George is my boss. He's a good guy, excellent guy, and I thank him for this opportunity to be up here and talking to y'all, because Raytheon, I don't believe, would let me do this unless I jumped through like 4 hoops and spun plates on my head. So just getting down to those procedure level is what we're after, and that's what's going to drive detection engineering, and that's what's going to make us threat informed. So that's pretty much the whole talk, and then we'll open it up to questions now. Kind of rush through because I do want to make sure we have enough time for questions, but just to tie it off, I do want y'all to have some happy hunting, and I hope y'all actually go out and find good cyber threat intelligence, understand that adversary, what they're doing in your environment, or what they would do in your environment, potentially, run that in your environment, and then start doing detections around that. So any questions? Yes.
How do you feel about risk-based alerting versus more of a traditional one-to-one detection response?
Risk-based alerting. So it kind of just depends, right? I don't think I've ever seen like where like risk-based is necessarily like, how do I put this? I've never seen it where like it works well, right? Because if I go out and I say, all right, I'm going to quantify this risk of this alert really high because it's on a domain controller. All right. Well, so if I have Mimikatz on a domain controller, I just got a high alert, hopefully, because I have a high asset and I have a high fidelity alert probably of very malicious activity. So now I have a high alert, but sorry about that. The issue is, well, what happened when the way the actor got in, who got to the domain controller and put Mimikatz on there? What happened to that low level informational alert in HR that was ranked low? So that's one of those things where, to me, tuning an environment and being able to respond to every alert, that's the idea. Is it achievable in every environment? No. I mean, some environments, it's very difficult to do that. But yeah, risk-based, it's one of those things I haven't seen it work well yet. And like I said, it's because of Mimikatz gets on a domain controller and it's high alert, but we missed all these other alerts of how they laterally move there. The other thing that I like to talk about with detection engineering, that I think that our detection engineers need to know about, is being able to document what's going on in the alert. So, and what the response is. So like if you have Mimikatz on a domain controller and the SOC analyst goes in and they say, we removed Mimikatz from the domain controller. We did an AV scan and it's clean, closing case. Well, what you have to know is that means that there's still an adversary with active C2 somewhere in there. They actually didn't do the response well. So when you're doing purple teaming, you need to also audit that response to make sure we're getting the appropriate response. One of the most common ways for threat actors right now to get command and control up and running from, most of these phishing campaigns, they're using something where they like inject either the initial Trojan, or afterwards when they drop Cobalt Strike, it'll go into run DLL32. So one of the areas that we're running into issues is you see where an analyst will say run DLL32 alerted, and we have the alert. And this is why you don't stop when you're purple teaming. You don't stop at the alert. You need to get to the next level and test the human response. Because if I put my shell in run DLL32 and it's calling out bound, that's great for me. I'm hiding right there. And then the analyst will go in and then they'll take the hash of the run DLL32 process, and then they'll also say that it's Microsoft signed, and then they'll close the case saying that it's a false positive. So this is one of those areas where if you're a red teamer, try to help guide people through the whole process of, look, we need alerts. We need to test the response to it. And then where we don't have alerts, we need to gain alerts. And then we need to test the response to those. We need to constantly be hardening and scrimmaging against ourselves, so that when the adversary shows up, we're ready and we're going to win. Thank you. Any other questions? Yeah, what's up? Parent process ID? Yeah, so for those online, the question was, do we ever run into parent process ID spoofing? I don't believe I ran into it in the wild, but there are detections around that. And it also depends like how it's done too. But that's one of those things where you can do it. It is a technique, but that's where we want to go in and we want to see the actual process that was done, replicate that whatever the adversary is doing, how they're actually doing it, and test it in our environment and test it against our tools. Does that make sense? So like with any technique, there's so many different procedures. So you'd have to look at the specific procedure and how it's doing. But yeah, definitely you should be hunting for that. Any other questions? So for those online, the question was, how often should we be testing the rules or content? Now, this is one of those things where you could have a test after every change management. So if you change your rules, one of the things that people are pushing right now is detection as code. So every time you change your code, then you want new detection tests. You could do something where you're looking at a monthly test of what you're actually seeing in your environment or from your adversaries. One of the best areas to get your best CTI is to go out and look at all your blocked emails and any of your emails that actually got through that were phishing, and then studying that whole chain of what it looks like from the user click. It might be, an ISO file that then launches like a .bat file that then launches this, doing that. And then instead of launching that actual process in your environment, or that actual malicious activity in your environment, figure out a way to emulate that in your environment and then see what would happen. Like, okay, we knew that this came in, 5 users got it, and we removed it from their inbox. No one ever clicked it. But do you know that you have, if someone does click it and you don't get an alert, do you have those capabilities after that click to start catching that chain? So that's one area that we look at.
Yeah, so I just want to get back to your smiley face diagram, the malicious activity. So obviously, we have really good rules that catch malicious activity all the time, but it doesn't catch enough. You have too many benign events, and you have too much dopamine in your system, right? And so, what is your approach on both sides of it? Where you go, how do you process in your head? Okay, what am I going to do to this alert that's going to make it higher fidelity?
So the question is what do you do to an alert to make it higher fidelity? So you have to understand two concepts, and one concept is, if I have it, nope, not on here, is recall. So recall, and this is pivoting from what MITRE's done with a bunch of their research, and they look at it more from a very advanced data science aspect, is recall is how much of the malicious activity do I actually detect? So that's one area. But with that too, you have to identify potential unknowns, right? Or consider potential unknowns in your detection. And then the other area is precision, because we don't want benign events. So it's trying to balance those two out, that we get something like this, where we're going for the most recall we can, and then we're also trying to balance out precision and not have a lot of false positives. But the way to do this the best way is to run a bunch of different procedures for whatever you're trying to detect. So if you're trying to detect encoded PowerShell, maybe you want to do a base 64 encoded PowerShell. And then maybe you're still looking at PowerShell, so you want to do something like invoke obfuscation PowerShell. So you want to start looking at different things like that to see how your detections can be expanded, or if you have to go into new detections. But obviously, and I'm doing the thing again, once again, people have patterns. This is why we go out and we look at the patterns that they're doing. Yeah, what's up?
Is there a balance in creating a broad enough scope of detection not to miss anything while managing?
Is there
Is there a balance in creating a broad enough scope of detection not to miss anything while managing alert fatigue?
Okay, so the question is about getting to balancing detections so that you don't get to alert fatigue. So yeah, that's where we're here, right? You have too many benign events. And the way we do that is we got to get down to something like this, where we're not alert fatiguing our SOC. And the way we do that is we go through our questions. We're looking at different parent processes or child processes that we can tune out. So like I said here, we looked at the parent processes, so we tuned these out so we didn't have alert fatigue. Now, obviously, something else could come along eventually, especially like if there's like an install or something like this, that might trip it. But we're not going to have alert fatigue from this. We'll catch some suspicious activity, but not alert fatigue. So it's just about doing that tuning. Any other questions? Yep. What's up?
So a lot of those things revolve around host-based detection, meaning that you need some way of detecting on the host. Have you ever dealt with, or and maybe how have you dealt with the organization? Can't do that at scale, right? Because when you talk about host-based detection, depending on how many hosts you have, doing it at scale can be very difficult or very costly.
Right. So the question was around a lot of these detections are host-based. So one of the big things that you have to understand, if we go back to it real quick, is to actually catch a fair amount of the techniques. To actually catch a fair amount of the techniques, we actually do need command execution, and we need process creation. One of the first things that typically happens with modern day incident responses is they come in and they throw an EDR on there because you need those hosts or that host data. So from there, to address your question, is if you have someone who doesn't have an EDR deployed yet, most often they also don't decrypt SSL. So you're also not going to be able to look inside that traffic either to do the network side. So now you're pretty much flying blind. So what do you do? Well, what we did one time was we had a case study where we got charged with improving detections without spending any more money. And what we did was is we deployed Sysmon so that we actually got the logging capabilities that we needed and the alerting capabilities. And then so from Sysmon, if you're not familiar, great tool. And then look at Olaf's modular config. It's a great one. And then you also have the common Swift on security config as well.
Just trade labor costs for point costs. The points is on managing that instead.
Potentially, yes. But it is a cheaper route. And then, oh, by the way, another way of actually doing a good substitute, Florian Ross company, actually, Nextron, I believe, they came out with a Aura agent, and it actually runs on the host the signal rules. So it's actually great because you actually don't have to collect all the sysmon and then configure your SIM with the Sigma rules. You can actually just deploy this and then send whatever alerts come back. So it's a very powerful tool that I think a lot of people will start using as kind of a makeshift EDR for those type of setups where it's like, I need something on the cheap. Okay, go deploy this, and at least you're going to have those EDR alerts, even if you don't have that EDR visibility. But now you know which system to go get and start looking into, or deploy Sysmon to, or whatnot. Great question. Anyone else? I think we got time for about 2 more questions. Yeah, what's up?
That's like, how do you feel about secondhand detection? What I mean by that is like, think of your MCAS or any other product student correlation kind of black box. How do you handle companies who are like, hey, I want that alert one-to-one? You don't have any idea of the logic, you really can't tune it well. They want that as a detection.
All right, so the question is when you have like a company who doesn't tell you why a detection fired, but the customer also wants that detection in a different environment. Probably talking about Mandiant if I had to guess. Google now? I think it's Google. So yeah, that's going to be a tough one, right? But what you can do typically is if they wrote at least the alert well enough, you can get an idea of what it's flagging on. Or what you can do is because a lot of them now are tagging to at least a technique level, so you can probably go, start doing some different procedures. Maybe start with like some atomic reds for that technique until that alert fires again, and then now you know what that technique was, and then you can map it to something that's internal to you or like a Sigma rule. If that makes sense. But yeah, you can. I mean, if you ham jam it enough, you'll figure out what fires that sucker. All right, come on. We got questions. One more.
How are you updating your TCP thread?
All right, so the question is how are we updating our TTPs and threat actor information? So this is like a tough area, right? Because a lot of reports don't contain procedure level intelligence. And so what we actually have done is we went out and we hired Jake Williams, who's a former, I don't know if I think he comes out, he's publicly said he worked for a 3-letter agency. And he's a SANS instructor. He wrote like the top SANS, the hardest SANS course, which is like advanced exploit development. So we went out and we hired him. If you are on Twitter, Malware Jake, shout out to him. He's been awesome so far, and I'm sure he's going to do even more amazing stuff. So we're going out and we're actually building out how to get more procedure level in-house. But the other area that we're looking at is what you can do right now is go out and read reports. So in the instance that I showed you where we actually had the Microsoft report, let's see. Yeah, so we had the Microsoft report, and we can see right here what they're doing. So it's one of those things where you have to go through a few reports. OpenCTI is actually pretty good source where you can get through multiple reports until you find procedures. But it's going out, reading the intelligence, that's actually produced. This is one of those things too. Most of the time, what we're doing, if you're doing detection engineering, you should be a consummate consumer of cyber threat intelligence. You should go out and read the intel reports. So if Mandiant is coming out with a report of what a threat actor is doing, if Microsoft's coming out with a report of what a threat actor is doing, you should be reading it and understanding what the adversary is doing. And then you can understand that at a procedure level of what they're doing. Let's do that in my environment. Can I detect it? Do I have response around it? And that's what we're really trying to do. Purple teaming, it was like the first thing where I was like, that makes sense to do. Like ML AI, sure, that stuff's coming eventually maybe, but purple team, that's the most actionable thing we can do right now to actually harden our environments. And if we just did it a little bit more, we wouldn't be getting the ransomware that's across all these organizations with Conti playbook being ran over and over and over again. I hope they talk about it in the next talk, but literally it's the same thing, NL test, net.exe, all these things over and over again, where if you actually had just a little bit of knowledge of how to consume the reports coming from like the DFIR report, how to actually just go out, read it, think about it, emulate it in my environment, and then test my detections and response against. So with that, I believe I have to wrap up, but happy threat hunting, happy detection engineering, happy purple teaming. Get out there and kick some butt, and let's get these adversaries off our networks.
Oh, by the way, there are stickers on either side of the stage. I moved them all there. So you should get it.
I should have checked it after I did.